All right, we're going to talk about energy conversions today. All right, we're not going to talk about this until I come back from the workshop, so don't write that. We're going to talk about kinetic energy converted to potential energy and potential energy converted back into kinetic energy. Okay, so what did we say kinetic energy was on Monday? Kinetic energy is motion. Okay, potential energy is height. I want you to keep those two things straight in your mind. Kinetic energy is motion. Potential energy is height. Okay? So we're going to do this, and we're going to look at some pictures. Now, you should have watched a video on a roller coaster that was 2 to 3 minutes long before you watched this video. Okay? Now, if you need to, pause the video and write that down. Now, first thing we're going to look at is a ball rolling down a hill. Now, we want to be able to label where we have maximum potential energy. Maximum potential energy. What did we say potential energy was again? Potential energy is height, right? So maximum potential energy is always the greatest height. So if we label the balls 1, 2, 3, the greatest height or greatest position is at 1. So maximum potential energy is going to be at position 1. Now, if we want to do maximum kinetic energy. Maximum kinetic energy is motion or velocity. Now, another word for velocity is speed. So where will the rolling ball have the greatest speed? All right, speed is always the greatest at the bottom. Okay, never in the middle. It's always the greatest at the bottom. So the maximum kinetic energy is always going to be at the bottom or the lowest point. So the maximum kinetic energy will be here. Now, if we want to talk about minimums, sometimes they'll ask for minimums. Excuse me, they're the opposites. Okay? So if we look at minimums, all right, minimums are opposite. So if I say minimum potential energy, minimum is just going to be the opposite. So if this is max, that's minimum. What's the opposite of kinetic? Potential. So that would be the minimum potential because it has the lowest height. If this is maximum, that's minimum. What's the opposite of potential? Kinetic. Okay, now, this is in the middle. Is the middle point ever anything? No. Question?
Oh.
All right. Most of y'all play basketball, have played basketball. So this should be an easy one for us to label. So if we look at 1, 2, 3, 4, 5, 6. Again, think about what you know in positions. Again, potential energy is height. Kinetic energy is motion or speed. Okay, so what did we say? Potential energy was height. Speed is always at the bottom. Okay, so if we want to label where the most potential energy is at, where's the greatest potential energy going to be at in the diagram? The greatest potential energy is going to be here. All right, the maximum potential energy will be here. Where will the maximum kinetic energy be? Maximum kinetic energy is always going to be at the bottom. Now, we need to add in another piece to this. You good, Jada?
Yeah, I forgot you posted on the website.
Okay, yeah, the answers are on the website. Now, from there, we have to talk about the converting. And what happens is things go up and things go down. All right, so if we go from kinetic to potential, we go up. You're welcome. Does kinetic energy increase or decrease? Well, what happens to the ball? Does the ball speed up or does the ball slow down? All right, as the ball goes up, the ball slows down. All right, well, if the ball slows down, that means kinetic energy will decrease. Anytime we slow down, that means kinetic energy decreases. Now, when we speed up, that means kinetic energy will increase. Think about it in a car. We've all driven, we've all ridden in a car. If you go down a hill, the car goes faster. So when the car goes faster, your kinetic energy increases. When we go down the hill, we're increasing in kinetic energy. We go up the hill, car gets slower. We have to push the gas pedal more. That's because kinetic energy is decreasing. Now, the flip side of that is potential energy. What can you tell me is happening to the height? Okay? As we go up, all right, as we go up, height does what as we do that? Height increases. So potential energy will increase as we go up. What happens to height as we do this? Height decreases. So if height decreases, potential energy decreases. You have to look at what's happening as you go up and you go down. So if we go back to the picture that we just drew, all right, as we go this direction, what is the ball going to do? Is it going to go faster or is it going to go slower? Since it goes faster, kinetic energy does what? Kinetic energy increases. Now, since the ball is going down the hill, what can you tell me about the height? It's going down the hill, right? So potential energy will decrease because the height goes down. As the height is less, potential energy decreases. Now, if we look at a roller coaster, let's say that I draw some ugly little cars on the track. We put some numbers on them. 1, 2, 3, 4, 5. Okay? And again, we want to identify the maximum potential energy. Where would the greatest potential energy be? Well, where's the greatest height? The greatest height is at the top. So the maximum potential energy is there. The maximum kinetic energy is always where? Maximum kinetic energy is always at the bottom. So the maximum kinetic energy is always going to be there. Okay? Now, if we want to do the minimums, okay? Remember, they're opposites. So this would be the minimum what? The opposite is kinetic energy. The opposite is potential energy. Now, again, you also need to be able to tell if it's increasing or decreasing. So, in the roller coaster lab, you're going to have to be able to talk about that. So, as we go this way and as we go that way. All right. What can you tell me is happening here? As we go down, do we get faster or slower? If we go down, we get faster. So if we're getting faster, kinetic energy does what? It increases. But as we go down, height does what? Height decreases. So if height decreases, potential energy will decrease. Now, what happens as we go up? If we go up, we go slower. Anytime we go slower, kinetic energy will decrease. But height increases. So if height increases, potential energy will increase. All right. So, same concept. Look at the direction of the arrows. Look at the numbers. I want you to try to label maximum KE, maximum PE, increasing kinetic energy, increasing potential energy, and velocity equals 0. So, if we look at this, all right, where do we start at? Where's the greatest kinetic energy? The greatest kinetic energy is always where? The bottom. So maximum kinetic energy is there. Maximum PE is always at the top. So there are how many maximum PEs? They're always at the top. So there and there. Now, where does kinetic energy increase? Where it goes down or where it goes up? Where it speeds up, right? So this is where it's going down. So that has to be increasing kinetic energy. Here, let me change colors. This is where we're going down. So that has to be increasing kinetic energy. Now, increasing potential energy has to be where the height gets bigger, okay? Because this one speeds up or goes down. All right, increasing potential energy has to be about height increasing. So where's the height get better? That's here, okay? The height's going up. So that has to be increasing potential energy. And then where's the velocity 0? Velocity equals 0 means it stops moving. So this is a pendulum or a swing on a swing set. Swings back and forth, back and forth. So where does it actually stop moving at? It stops moving at 1 and 5. So it's actually equal to 0 here and here, because for a split second, the pendulum stops moving. Okay? Now, from there, you're going to work on a review sheet. Colonel will evaluate time and decide what happens next.